Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. So, in today's section, I'm going to discuss about the empirical formula problem, students, some basic concepts of chemistry. In this section, I'm going to discuss about the previous year question solving, students. This is the day 1 schedule NEET preparation series day 1. So, in day 1, I'm going to discuss about the empirical formula problems previous year question, students. Okay, Nama? Now see, students, just to save the time, before only I wrote this question, students, problem. An organic compound contains C is equal to 40%, carbon 40% given, hydrogen 13.33% given, nitrogen 46.67% is given. Its empirical formula is asking question. Okay, now you have to find the empirical formula. So we know that in the last sections we discussed, students, what is empirical formula. Empirical formula is nothing but simplest form of the molecular formula, correct? So that is nothing but empirical formula. So problems how to solve an empirical formula, how to find. See here, students, here, so here I'm taking total 5 columns, Nana. Total 5 columns. First column is element, atomic mass, percentage of mass, number of gram atom, simplest ratio. Total 5 columns I'm taking, students. Okay, now so first, which elements are given here? First I'm going to write which elements given in the question. Carbon given, hydrogen given, nitrogen given, correct? 3 elements given. So first, what elements given, that you write first, students. In order wise only write, students. Okay, now first carbon there, next hydrogen, third element is nitrogen. 3 elements are right here. So carbon, next hydrogen, next third one is nitrogen. 3 elements given. Are you clear this one? Carbon, hydrogen, nitrogen given. Next, what is the atomic masses? Tell me, students, what are the atomic masses of carbon, hydrogen, nitrogen? Carbon atomic mass is 12, hydrogen atomic mass 1, nitrogen atomic mass is 14, correct? 14. Next, percentage of mass. What percentage, students? Here carbon percentage, how much given, students? 40% given. So write that 40%. And next, hydrogen percentage, how much given, students? 13.33% given. And nitrogen percentage is 46.67% given, students. Okay, next we have to find the number of gram atoms. How to find it, number of gram atoms, students? See here, so this 40 percentage by atomic mass you have to calculate. Percentage of mass by atomic mass, if you calculate, you will get the number of gram atoms, students. So that's why what I'm doing here, 40 by 12 I'm doing, students. 40 by 12, 13 by 1. Okay, 13.33 percentage given na, by 1. And next 46.67 by 14. Are you understanding? So here what I am doing, percentage of mass by atomic mass, 40 by 12, 13.33 by 1, this by this one. Now how much, students? 40 by 12, I am going to calculate 40 divided by 12. 40 divided by 12, how much, students? 3.33. Clear? 3.33. We got 3.333, or we can take up to 2 digits, students. 3.33 also we can take. Okay, 13.33 by 1, how much you will get, students? 13.33 by 33 by hydrogen 1 na, atomic mass, so you will get 13.33 only. And next 46.67 by 14. 46.67 divided by 14, how much, students? This is 3.33, correct? Now in these three values, students, which is the smaller value, students? Which is the small value? 3.33 na. So which is the smallest value? That with that value you have to divide these three values, students. So that means 3.33 by 3.33, 13.33 by 3.33, 3.33 by 3.33. Clear this one? 3.33. That means, see, which is the smallest value in these three values. Okay, now. So in these three values, which is the smallest one? With that value, you have to divide all the values, students. Understanding? So what we are taking? Smallest value you have to take. Are you clear? So smallest value you should take. With that smallest value, you have to divide all the three values, students, then you will get this one. Now tell me, students, 3.33 by 3.33, how much, Nana? You will get value 1. This 13.33 by 3.33, how much you will get? 13.33 divided by 3.33. 3.33, how much, students? 4.00 we got. That means answer is 4.0. And this value also 1 we got, correct? 141. So simplest ratio, so here we can write it as simplest ratio. It is also it is 1 only, simplest form it is 4 and 1. We cannot write still in the simplest form, correct? That values only as it is you can take 141. This is the simplest ratio. So we know that empirical formula is nothing but it is nothing but simplest ratio, correct or not? So here how many carbon, students? Here simplest ratio carbon, how much we got? 1. So that's what is the question. What asked, students? Empirical formula is asking. What is? Calculate the empirical formula. So empirical formula, how much, students? Carbon 1. Okay, now carbon 1, hydrogen how much, students? 4, and nitrogen how much, Nana? 1. Clear? Carbon 1, hydrogen 4, nitrogen 1. So what is the empirical formula, students? So what is the empirical formula? See here, empirical formula is equal to CH4N. Clear? C, carbon 1, hydrogen 4, nitrogen 1. So this is the empirical formula, students, CH4N. In the question only asked empirical formula, so that's why like this we have to find it. Ardhaitama? Understood, Nana? So first, which elements are there? That you write first. Carbon, hydrogen, nitrogen, their atomic masses, right? Percentage of mass. How much percentage given in the question? That percentage is right. Number of gram atoms is nothing but percentage by atomic mass. Then you will get the number of gram atoms. Here you got three values. In these three values, which is the smallest value, you have to divide with that value with all the values, Nana. Okay, then you will get 141. This is the simplest form. That values you have to write. Then you can write the empirical formula. Now see, students, second problem. Second problem, what given here? This is a different model question. Here direct percentage not given, students. See here once. 0.30 grams of an organic compound containing carbon, hydrogen and oxygen on combustion yields 0.44 grams of CO2 and 0.18 grams of water. If 1 mole of compound weighs 60, then molecular formula of the compound is asking, students. Here not given any percentage, only weights given. CO2 weight, water weight given 0.18 grams. Total organic compound weight 0.30 grams given. So first what you have to do, students? We have to find the percentage of the carbon. Okay, the percentage of carbon, percentage of hydrogen, percentage of oxygen, we have to find it. They given weights, Nana. So by using these weights we can find the percentage of carbon. So first I am going to calculate the percentage of carbon. See, students, percentage of carbon, how to find it? Percentage of carbon is equal to, how to find it, students? Carbon. So CO2, in CO2, Nana, how many carbons are there? Only one carbon. So carbon atomic weight is 12 divided by CO2 molecular mass is how much, students? 44, correct? CO2 molecular mass, carbon 12, 2 oxygens kada, 2 oxygens means 32, total 44 is the molecular mass, correct? So in CO2 carbon 1 atom is there, that's its atomic mass is 12 by total mass of the molecule 44 into how much CO2 weight given, students? 0.44 weight given. Total organic compound mass how much? 0.30. Are you following? So total the CO2 weight by total organic compound weight is 0.30. Okay, now so like this you have to find it into 100. Then how much you will get, students? Into 100. 12 divided by 12 into 0.44, sorry, 0.44 into 100 into 100 into 100, next divided by 44 Here into 0.30 nama, in the denominator 44 into 0.30 is there, into 0.30 you should not do, again divided by you have to do nana, divided by 0.30, 0.30 students, then you will get the value. How much you will get students? 40% you got answer. Percentage of carbon is equal to 40%. Clear this one? So this is the percentage of the carbon. Now I am going to calculate the percentage of the hydrogen students. Percentage of hydrogen. Percentage of hydrogen, how to find it students? Here in the formula water molecule, hydrogens, how many are there students? 2 hydrogens are there, that's why 2 atomic mass of hydrogen. H2 is there na, that's why 2. Total water molecular mass is how much students? 18 na. So H2O means 2 hydrogens are there, 2, 1 oxygen is there, 16, total 18. So 2 by 18 into how much weight given students? Water weight 0.18, total organic compound mass 0.30. You have to multiply like this into 100. Then how much you will get students? 2 into 2 into 2 into 0.18, 0.18, next into 100, divided by 18, again divided by 0.30. How much students? 6.66 into 100, 6.66 percentage, 6.6 percentage we got. Okay now, so this is a hydrogen percentage. And next here oxygen also given, and oxygen on here 3 elements given: carbon, hydrogen and oxygen students. So oxygen, how to find it students? Oxygen, here oxygen to calculate, just how to find it? See here, percentage of oxygen is equal to 100 minus of these 2 elements add nana, 40 plus 6.6, then you will get 100 minus 46.6. Then you will get answer 100 minus 46.6, 100 minus 46.6, 46.6. How much students? 53.4 percentage we got. This is the oxygen percentage. Clear this one? 53.4 percentage. So in this question students, they didn't give any percentages of elements, just the given weights given. Okay now, so this is the process students. You have to find the percentage of elements, then you have to calculate the empirical formula students, then after that molecular formula we can find it. Clear this one? Now see students, after this, what is the first column students? Element. So first column is element. Okay, element. And second column, what is the second column students? Element, atomic mass, atomic mass. And third column is percentage of mass, percentage of mass. And fourth column, number of gram atoms, number of gram atoms students. And last column is simplest ratio. Okay, simplest ratio. So like this, total 5 columns I am taking nana. So already in the last question I discussed na, as it is I am taking. Now see students, element. Now coming to the element students, here which elements given? Carbon, hydrogen, oxygen, correct? Carbon, hydrogen, oxygen. So here I am taking carbon, hydrogen, oxygen. Okay, now oxygen. What are the atomic masses students? Carbon atomic mass 12, hydrogen 1, oxygen 16. What is the percentage given students? Percentage of carbon we calculated already. So can tell me 40%. This is 40. This one is 6.6 percentage. This is 53.4 percentage. How many gram atoms students? The number of gram atoms. The number of gram atoms is equal to percentage of mass by atomic mass. That means 40 by 12 students. This is 6.6 by 1. This is 53.4 by 16. 40 by 12, how much students? 40 by 12. 40 divided by 12. Okay, then how much you got? 3.33. 3.33 you got. Okay, next this one, see students, 6.6 by 1 means 6.6 we got. 53.4 by 53.4 divided by 16 given. Okay, now 53.4 by 16. How much we got students? 3.33. Are you clear? So in 3.33, 6.6, and next see here 3.33, 6.6, 3.33. In this, which is the smallest value students? 3.33, correct? This is the smallest value. Smallest value, correct? This is the smallest value. This is also 3.33, that only smallest value. So we have to divide the same, divide this all the three values with 3.33 students. Then how much you will get? 3.33 by 3.33, 6.6 by 3.33, 3.33 divided by 3.33. Are you clear this one? Then how much you will get students? This one time. This one how many times students? 2 times. 2.2 you will get. This value 1 you will get. Yes or not? So how here 1 2.2, 6.6 by 3.3 is nothing but you will get answer. How much students? 2.2. So you can write it as simplest form. So 1 we can write it as it is. 2.2 we can write it as 2 and 1. 6.6 by 3.33. Now once we will check it. 6.6 by 3.33. 3.33. How much students? 1.98. So this answer is 1.98. This it is nearly equals to 2. We can write it as simplest form 2. This is 1. Are you clear? So 1 to 1. Understood, Amma? This is the simplest ratio. That means carbon is 1, hydrogen 2, oxygen is how much students? 1. Okay, now hydrogen is 1. Now see here. So what is the empirical formula? So we have to write first empirical formula. Empirical formula is equal to what elements given students? Carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Carbon 1 atom. Okay, now hydrogen how many? 2 atoms. So oxygen 1 atom. Okay, now 1 to 1. Carbon, hydrogen, oxygen. So empirical formula is equal to carbon, hydrogen, oxygen 1 to 1. So we can write it as CH2O. Are you clear this one? CH2O. So this is the empirical formula students. But question is what students? Molecular formula is asking. So molecular formula is equal to what is the formula students? How to find it? Empirical formula into N. Empirical formula into N number. Okay na? So N is what students? But here we don't know N value. So first we have to find the N value. What is N students? Molecular formula mass by molecular formula mass by empirical formula mass. Clear? Empirical formula mass. So what is molecular formula mass? In the question already given molecular formula mass. See here. Then if 1 mole of the compound weighs is 60 grams, that means 1 mole of the compound molecular weight how much given students? In the question 60 given. We have to find the molecular formula. Okay now. So molecular formula weight already given in the problem C students. So molecular formula mass is equal to how much given? 60 given, correct? 60. Molecular formula mass is equal to 60. And next empirical formula. So what is empirical formula mass students? Empirical formula we know that CH2O na. So first you have to find the empirical formula mass. Okay, you calculate. CH2O na, carbon atomic number 12, 2 hydrogens are there, 2, 1 oxygen is there, 16. Total how much students? 30, correct? 60 by 30. This is the empirical formula mass. So how much nana? 60 by 30 empirical formula mass. Then how much you got? 2 you got. N is equal to 2 nana. So N equal to 2 here substitute, then you will get the molecular formula. So molecular formula is equal to empirical formula into N. N value how much nana? 2. What is empirical formula students? CH2O 2. Clear? CH2O2. Then how much you will get, students? C2H, 2 2s are 4, O2. Clear? C2H4 O2. C2H4O2. You have to multiply, students, here. 2 2s are 4. Here carbon 1 atom, na? 1 into 2, 2. Oxygen 1 atom, 1 into 2. This is the molecular formula. Clear this, students? This is the molecular formula. Okay, na? So like this you have to find it. So these are the formula, students. Empirical formula, molecular formula is equal to empirical formula into N. So this is the formula, students, you have to remember. And N is equal to molecular formula mass by empirical formula mass. This is the another formula, you have to remember this one. Then only you can calculate the molecular formula. Understanding, students? So what is the answer? C2H4O2. Where is the option, students? C2H4O2. This one, C2H4O2. So which option is correct, students? C2H4O2. B option is correct. Clear this one? In the first question, what we got? Molecular formula CH4N. So which option is correct? C option is correct. Understanding? CH4N. Adhaitama. Next, last question, students. Last question, third question. See here, this is the different model problem. See here, empirical formula of the compound is CH2O and its molecular mass is 90 given. The molecular formula of the compound is asking. So how to find it, students? Empirical formula given. So empirical formula is equal to CH2O given, Nana. And its molecular mass is how much given? Molecular mass given. Okay, na? So molecular mass is equal to 90 given. Okay, na? How much given? 90 given. The molecular formula is asking. We have to find the molecular formula. Okay, na? So what is the molecular formula, students? We know that molecular formula is equal to, what is the formula, Nana? Empirical formula into N, correct? Empirical formula into N. But N is what, students? N value we don't know. What is N formula? How to find it? N is equal to molecular mass by empirical formula mass, correct? Empirical formula mass. Now see, students, molecular mass already given 90 by empirical formula mass. Empirical formula also given CH2O. Calculate first empirical formula mass. Okay, now empirical formula mass. How much, students? CH2O. Na? So carbon 12, 2 hydrogens. How much? 2 hydrogens, 2, 1 oxygen 16, total 30. Okay, na? Total value how much? Empirical formula mass 30. So how many times, students? 3 times. So N value 3 we got. This value here substitute. Then you will get the molecular formula. So what is molecular formula, students? Molecular formula is equal to empirical formula into N. Empirical formula is CH2O. N is how much, students? 3. Then what is the molecular formula? C3H6O3. Clear this one? C3H6O3. Now what is the option, students? In this options, 4 options, what is the correct answer? A option is correct. C3H6O3. Clear, students, how to find it? Empirical formula given, molecular mass given. Molecular formula is equal to empirical formula into N. N is equal to molecular mass by empirical formula mass. So these two are the formula, students. Okay, now these two are formulas important. You have to practice these two formulas. Clear this one? So this is the formula and this is also formula. Understanding? So this is about the empirical formula problem, students. These are the previous year papers questions, Nana. I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, Nana.